All right, let's dive right in. Welcome to this explainer. Today, we're going to completely demystify a technology that is so ubiquitous, it's practically invisible. We all talk about the cloud, right? We save our photos to it, we stream our favorite shows from it, and entire global businesses run on it. But what exactly is it? If you've ever felt like the cloud is just some abstract floating concept that you use every single day but don't quite understand, you are in the exact right place. We're going to break it all down, make it concrete, and show you exactly how it all works. So let's just shatter an illusion right out of the gate here with a pretty provocative question. Where does your data actually live? Because, spoiler alert, the cloud isn't actually in the sky. It's not magic. When you binge watch Netflix or hit save on a new document, a very real physical reaction is happening somewhere on Earth. Your data has a physical address, and understanding that is the absolutely crucial first step to truly understanding cloud computing. Here is our roadmap for today. 1. Demystifying the cloud. 2. A brief history of cloud. 3. How cloud architecture works. 4. Choosing your cloud model. 5. The perks and perils. And 6. The data sovereignty challenge. Let's get to it. Demystifying the cloud. Okay, so the National Institute of Standards and Technology officially defines cloud computing as a model for enabling convenient, on-demand network access to a shared pool of configurable computing resources. Wow, that is a mouthful, right? But honestly, just think of it exactly like a public utility, like your electricity. You don't build a massive power plant in your backyard just to turn on a lamp, right? You just plug into the wall, tap into a shared grid, and pay only for the electricity you actually consume. Well, cloud computing is exactly that, but for computing power, storage, and software. There are basically 5 essential characteristics that make the cloud work. First up is on-demand self-service. That just means you can get server time or storage instantly without ever having to talk to a human. Broad network access means you can get to it from anywhere, your phone, laptop, or tablet. Resource pooling is that shared utility concept we just talked about. It's multiple customers using the exact same massive physical resources seamlessly. Rapid elasticity is huge. It means that to the user, resources appear totally unlimited and can scale up or down instantly. And finally, measured service means everything is tracked, so you only pay for exactly what you use. Section 2. A brief history of cloud. Believe it or not, the seeds for all of this were actually planted way back in 1963. That's when DARPA funded MIT to figure out how 2 or more people could use a computer simultaneously. Then, in 1969, a visionary named J.C.R. Licklider proposed what he playfully called the Intergalactic Computer Network. I know, it sounds like pure science fiction, but his fantasy of a globally interconnected network where everyone could access information from anywhere is basically the exact reality we live in today. Fast forward to 1999, Salesforce pioneers delivering software over the internet. And then 2006 is the real game changer. Amazon launches AWS and Google launches Google Docs, bringing the modern cloud to the masses. Section 3, how cloud architecture works. Because, like we said, the physical reality of the cloud isn't fluffy vapor. It consists of massive, heavily guarded buildings called data centers. Inside these buildings are literally thousands of physical processors, like Intel Xeons or AWS Gravitons, stacked in endless racks. And they're all connected by this incredibly intricate web of fiber optic cables and network routers. When you access the cloud, you are quite literally reaching out across the world to access one of these physical machines. So how exactly does your device connect to that physical reality? It basically happens in 3 steps. Step 1 is the front end. That's your laptop or your smartphone, the web browser, and the APIs that send your request out. Step 2 is the network, which is usually just the internet acting as this high-speed delivery service. And step 3 is the backend, which is the cloud provider's domain. This is where those physical servers live, managed by a virtualization layer, which is essentially smart software that chops up the physical hardware into flexible digital resources that can be assigned to you in milliseconds. Now, providers offer this backend in 3 main flavors, which we call service models. First, you've got IaaS, or Infrastructure as a Service. This is the most basic level. You are essentially renting the bare virtual servers and storage, like using AWS, and you have to manage all the rest. Next is PaaS, Platform as a Service. This gives developers a ready-made environment to build and test apps without worrying about the underlying servers. Think AWS Elastic Beanstalk. And finally, SaaS, Software as a Service, which is what most of us use daily. It's a fully finished application like Google Drive or Microsoft 365, where the provider handles absolutely everything from maintenance to security. You literally just log in and use it. Section 4, choosing your cloud model. Organizations basically have to choose from 4 main deployment models. You've got the public cloud, which is shared by the general public and owned by companies like Amazon or Google. Then there's a private cloud, operated solely for one single organization, which offers maximum control. A community cloud is shared by several organizations that have common concerns, like a group of hospitals that all share the same strict compliance requirements. But what's really fascinating today is the hybrid cloud, which weaves these together, binding private and public clouds with technology that allows data and applications to just move seamlessly between them. And that brings us to a really major strategic decision for IT leaders right now. Hybrid cloud versus multi-cloud. What's the difference? Well, a hybrid approach mixes your own private on-premises infrastructure with a public cloud. It's totally perfect for a highly regulated industry like a bank, which needs to keep sensitive financial data locked down privately, but still wants to use the public cloud for something like scalable analytics. On the other hand, a multi-cloud strategy uses multiple public cloud providers, like using both AWS and Azure. Why do that? Well, it practically eliminates vendor lock-in and significantly boosts global performance. A massive global retailer might do this to ensure lightning-fast speeds worldwide and to guarantee they literally never go offline, even if one provider has a major outage. Section 5, the perks and perils. So why has the cloud literally taken over the world? The perks, of course. The cost efficiency of paying only for what you use is an absolute game changer. It allows tiny startups to access the exact same world-class computing power as Fortune 500 companies. The rapid elasticity means a business can scale up instantly during a busy season, and global connectivity allows teams to collaborate seamlessly across borders. Furthermore, the massive processing power of the cloud is the engine driving our most modern innovations. It's powering everything from complex machine learning and AI to big data analytics. But, all of this convenience definitely comes with some real perils. Entrusting your data to third parties opens up massive risks for data privacy violations and unauthorized access. On a larger scale, dependence on foreign cloud providers can expose sensitive national data to surveillance or even cyber attacks. There is also a growing concern over monopolistic control, as just a few global tech giants completely dominate the market. And practically speaking, there's often genuine confusion over shared responsibility. Think about it. If your data is breached on a cloud server, who is legally at fault, you or the provider? Section 6, the Data Sovereignty Challenge. Listen to this quote from a recent legal analysis because it perfectly captures a huge tension we're facing today. Quote, each state has a different set of legislations dealing with data storage, privacy, and security. Being compliant with one jurisdiction's provisions would mean being non-compliant in another. It's wild, right? We have built a completely borderless digital technology, but we still live in a world defined by very strict physical borders and national laws. Just think back to that architectural reality we talked about a minute ago. Because cloud providers use a multi-tiered framework to ensure lightning-fast speed and redundancy, a document you create today might be physically stored on a server in Singapore, backed up on another server in Ireland, all while you are actively accessing it from the United States. And that creates a massive legal headache. Different nations are approaching this in entirely different ways. Take India, for example. They heavily emphasize data localization, meaning they want data generated by their citizens to stay within their borders to strictly safeguard national security and privacy, especially for things like banking. Conversely, the United States generally promotes free-flowing data across international borders, prioritizing market-driven solutions, technological innovation, and economic competitiveness. Now, neither approach is universally right or wrong, but the fundamental clash between them makes regulating the global cloud incredibly difficult. So, the ongoing search for a balanced framework is really the defining challenge for the future of the cloud. It's a tightrope walk. If regulations are too restrictive, it completely stifles the very technological growth and economic innovation that makes the cloud so valuable in the first place. But if regulations are too loose, we compromise our fundamental privacy and security. Cloud providers, researchers, and governments are really going to have to find a collaborative way forward to protect citizens while still allowing the technology to thrive. Which leaves us with one final, pretty vital question to ponder as we wrap up this explainer. As you go about your digital life today, utilizing all this incredible invisible infrastructure, if your data is stored in Singapore, backed up in Ireland, and accessed in the US, whose laws truly protect you? Thanks so much for joining me to demystify the cloud today. Keep questioning, keep learning, and I'll catch you in the next explainer.